Right, I think that should be enough time. So welcome everyone, thank you very much for joining. Got a great webinar today, all about Kubernetes and how they run on Arm. Very exciting. Something I'm not hugely familiar with, so I'm looking forward to learning. Yeah, just a few things before we kick off. We have a chat function on the right-hand side of the screen. So throughout the webinar, if you've got any questions you'd like to pose to Carlos, please do. He'll stop sometimes and answer them, or if not, we can wait till the end of the presentation, then we'll go through them. This meeting is also being recorded, so if anything's want to go back and revisit, you can watch it afterwards and share it around. So yeah, without further ado, I'd like to welcome our guest, Carlos Arilla of Giant Swarm, who's a technical product marketing engineer. So Carlos, great to meet you, and please, go ahead.
Hey. Welcome everyone. Thank you for giving me the chance to talk here. I am Carlos. I work at Giant Swarm as a product marketing, as Josh very well said. Just a brief presentation about me. I have more than 15 years of experience in IT. I've done a little bit of everything: sysadmin, IoT, DevOps, and now I'm more specialized on Kubernetes. I've always been an open source enthusiast, and here you have my first computer, a Sinclair TechX Spectrum, very nice computer. A little bit about me: I like all these things: sports, video games, books, music, and Star Wars, and everything like geek, I would say. And these are my three little helpers to debug Kubernetes clusters. They're very, very helpful. This is the agenda for today. We'll talk about a little bit about ARM, what's ARM, how they was born, and what are the main advantages of the ARM processors. Then I will talk about Kubernetes a bit and how we can run Kubernetes in ARM. And then all the applications that run on top of Kubernetes, how we can do all the conversions that will allow us to run them in ARM clusters. And then questions and so on. I don't mind if you have any question to stop any moment and answer if it's meaningful. If it's too different, I can leave it for the end, but don't hesitate to ask question anytime you want. So let's start with some context about ARM. 1985 was a nice year. I was already here. I don't know if most of you were here, but Norway won Eurovision. Come on. Spain, I'm from Spain, if I haven't said it, joined EEC, which is current EU, and there were many very good films. Super Mario Bros. Windows 1.0, nice. And that year, Acorn creates the first ARM processor. The first version was something like this, a coprocessor that worked in some special tasks for another processor, but then they created a full processor, and the architecture of the processor has evolved over time with many different versions, like V3 in this computer. One of the most successful ARM computers, which is the Raspberry Pi, it's already some years old, but it's still rocking and very well known. And now we have ARM in data centers too, like Graviton. We have in all the main cloud providers, they have the ARM machines. So now it's very easy to use ARM processors. And the best example is that probably all the phones you have in your pockets will have ARM processors. So they are everywhere. The main advantages is that the architecture is made for simplicity, so they are more efficient and especially interesting for mobile, because batteries are very important. Then the design of the ARM processor was multi-purpose, so there are different cores suited for different tasks, and that makes very easy to customize the performance that you have and get a very good performance per dollar. And now they are comparable. In the years ago, They say that, okay, mobiles are not so powerful. They are less powerful than desktop or laptop computers or x86 processors. But now performance is comparable, and sometimes we can say it's even a little bit better. And one of the keys of the success of this ARM platform was the licensing mode, because anyone can license the core and use them to make a customized SoC, so you can build your own phone, computer, or wherever around these cores. So you can customize to make everything you want. Focus on performance, focus on efficiency, or mix. So this allows all the computer and phone makers to customize these processors to make the features they want. So the main two features we are focusing today are power efficiency and lower cost. That comes from simplicity, and this is very, very important. We will see that the reason to use ARM processor is basically these two. Let's talk about Kubernetes, because Kubernetes is a complex thing. I always say that I once tried to explain Kubernetes to my wife, and then we both didn't understand Kubernetes. But I will try, because now we're here. Kubernetes is a system that is designed to run workloads to be resilient and to have high availability. It's designed for scalability. So the architecture is something like this. You have some machines running a control plane that will take care of scheduling and everything that happens in the cluster. And then you have some nodes that will run the applications themselves. This is designed to run containers. So this is one of the systems that started the cloud native, and it's been very, very important for the development of all these technologies. But many of you will have heard, oh, but it's super easy to install a Kubernetes cluster. You just take 4 or 5 Raspberry Pis and install one of these softwares that was almost out of the box, K3S, Micro Kubernetes, and then you have ARM cluster. Okay, so, okay, thank you for listening. My job here is done. If you have any question, you can tell me at the end. Okay, wait, no. Okay, we can have clusters very easy, but we are not talking about that. That is for home, for hobbyists, but we are talking about real professional applications. So let's see how real Kubernetes looks, at least to me. So I said, this is Kubernetes, control plane, nodes, but only this won't get you anywhere. You need things running on top of it. So once you install this, you need security, you need observability, you need networking, you need a way to deploy things here. You need to create external resources, maybe communicate with cloud providers, databases. All these applications need to run in the cluster too. And this is the most difficult part of Kubernetes, not just having the cluster. Having a cluster is easy. This is the difficult part. And on top of it, there are 100 of cloud, and the cloud native landscape is huge. There are a lot of applications there, and all these need to run in ARM clusters too. So to say, okay, ARM Kubernetes cluster are ready for production, we need to be sure that everything we need to make the application accessible from the outside, to make it reliable, are working. Let's see how we can design our clusters. There are different strategies, and I will name 3 that I see that are the more important. The first one is, okay, I have my cluster, my control plane. My control plane will be working on x86 nodes. So it's like before, but I will change my x86 nodes by ARM nodes. These ARM nodes will run the applications that I want, and the control plane will only just take care of things. What's cool about this? The control plane nodes are still x86, so you don't need to change how you deploy or how to configure your control plane. Many people has different systems to spawn clusters to add them to your infrastructure, and this allows you to change very few things and still work. And all the worker nodes are equal. This is important because in Kubernetes you usually don't need to say in which node do you want the application to run. Kubernetes will make that itself. And if the nodes are equal, it's easier for the system to schedule everything. What's not so good? There are a thing in Kubernetes called daemon sets, which are pods or applications that run in all the nodes. And that means it means they run in ARM nodes and in x86 nodes, because control plane at the end of the day are nodes. So this could be a possible issue if your image is not very well, if not ready to run both architectures. And you need ARM images for everything that runs in the worker nodes. You are not so efficient because half, or at least some of the nodes, are still x86. So you are not getting everything. When is recommended to use this strategy? When your applications, all of them have ARM version, then this is a good strategy. And you don't want to modify how you are creating your clusters. You have a complex system in place and you don't want to modify a lot of things. So this could be an easier step. Just create a node pool with ARM nodes, and that's it. Second strategy is more bold, and I would say for me is the best if you can do it. It's go full ARM. All the nodes in the cluster will be ARM, control plane, and worker nodes. What's very good about this? All the nodes are equal. This is an advantage because it's easier to forget about multi-arc images or things like that. You get the maximum efficiency because everything is ARM. You don't have any x86 nodes. But it has some problems. The first one is that you need ARM images for everything you run in the cluster. That means everything: observability, networking, security, everything. And you probably will need to build and maintain some images that are not publicly available for some of the applications. Another question is, Kubernetes is a very well-tested application, but it's not so well-tested in ARM clusters. So you will be treading unknown floor, and there might be issues in the applications that haven't been debugged because there was no reason to do it. This might happen. When it's good to use this application, this architecture is you have all your apps with an ARM version, so it's very easy to go full ARM. You are willing to change how you deploy your clusters, so you are flexible, you want to change, and you need to do some work to deploy all your clusters with ARM, and that's it. And you want everything. I want all the cost saving, I want all the efficiency, I want everything, performance. Then you need to go this way. And then a different strategy would be have mixed nodes. In this strategy, I don't really care if the control plane is ARM or x86. It will depend on things we already said about this. But we will have mix nodes. We have node pools with ARM processors. We have node pools with x86 processors. What's good about this? We can decide the control plane if we want to run it in ARM or in x86, and we can run apps with no ARM version. This is the most important, and I would say this is the only reason I would use this strategy. Is like I need to use this specific application that won't run in ARM processors. This is what we have. This strategy has many issues, possible issues with daemon sets, because you need to run them in all the nodes. That would be problematic. Everything will need to be multi-arc, which is more complex. And there's one more problem. When you use Kubernetes, this is a shared resource, so you need to set request and limits of resources that you are using in the cluster. And as you don't know the performance of the application in both architectures, and it very well might be different, you might need to set different limits. And this is a problem because this can't be done with current Kubernetes resources. So this could be a problem. And we need to manage what, as I said before, having all the nodes equal is an advantage because it's very easy to schedule. You just send applications to nodes indifferently. But now, if we have different types of node, we need to take care of where we are running everything. And this is complex. There are several mechanisms in Kubernetes, like node affinity, that you can say, you run this application in x86 nodes, this one in ARM nodes. But you are complicating things. And when you complicate things, there are more chance for failure, errors, and problems. And this again, you don't have all the ARM processors, so it's more efficient, it's less efficient. You don't have it all. This is the only reason to use it. When I need to use an app that doesn't have any ARM, any way to run in ARM processors. There is one important thing about Kubernetes that is you always have to test everything because all the applications I use in my day-to-day in Kubernetes probably are different that you use. So my experience will be relevant in some level, but the only way to be sure that everything you are doing in Kubernetes will work on ARM is trying yourself, is making a test environment, is running things and see where they break or if they work. In the development process in Cloud Native, I separated 3 different steps where this migration might be relevant. First is the compilation. If we are used to compile everything for x86, we will need to put in place some way to compile the application for ARM processors. Then there is the deployment or the CI/CD pipelines that you use to create all the artifacts that you need to deploy the applications in the cluster, test, everything that happens between my code is ready and compiled, I have my binary, and everything is running in the cluster. And there is another relevant part of the system, which is not part of the cluster per se, but is very well related, which is the image registry. It's where you are storing your images. And in my experience, I have I wouldn't say very much, but quite a few issues with multi-arc in the registries. So this is something that you need to take care, that you need to research and be sure that it speaks. So compiling for ARM, nowadays, I think this is pretty much solved. There are a lot of multi-arc ways to compile in all the languages. There are still some languages that are more complex than others, but I would say if you are using Java, for example, there is I would say, pretty mature ARM JVM, because basically Android and this thing is based on a language is very similar to Java. All the binary compiled language like C, Go, and others are very well resolved. There are a lot of cross compilers and things to do. And if you use an interpreted language, they will probably a very well a very good and mature interpreter for your language. So I would say this is probably the easiest part. You will need your research. You will need to be sure that you are using the correct tools, but this is a matter of trying and doing it. I'm more worried about CI/CD pipelines because this is a complex field. There are a lot of things that could happen there, and you need to be sure that you can do all these things. First, you need to build your images. When you are building your images, nowadays there are a lot of ARM computers out there because there's a famous brand with a fruit that decided to go ARM. But 5 years ago, it was very strange to have an ARM computer to compile things. So you needed cross compilation, you needed virtualization, and that wasn't ideal. So you need to be sure that you can do that you can cross compile, that you can build multi-arch images. There are several tools that allow you that. Docker BuildX, I think, is the most common. And it's, I would say, easy to use. But again, you need to do your own research. You need to try it. You need to check that your applications work very well with it. So there's something else you need to do. And then in a perfect DevOps world, after you build, you need to test what you are building before deploying, of course, because you all test before deploying, right? But in order to test ARM applications, you need ARM environments, you need ARM machines. For example, if you are using a self-hosted CI system, I'm thinking about Jenkins or something like that, you can add ARM workers and do this in native machines. But if you are using a hosted service, this might be difficult. I know that some hosted systems like Circle CI support ARM machines right now, but that's something you need to check and I need to ensure. And you don't need to remove your previous test. Like you still, while you are changing, you'll probably be months or even years using both architectures, ARM and x86. So you need to be able to perform tests in both architectures, which means that it will probably be more expensive and will need more time. And then deploy. You need to be ready to deploy in ARM. The manifest need to have the architecture in there, so it's easier for the nodes to know which architecture are you using. And you need to be sure, as we said before, if we need something to clarify to the cluster which application goes in which node, you need to do that. Instant toleration, node affinity, all those things, you need to do that. So there are several things you need to do in order to get everything ready. And this requires time, a lot of time. So this is not a matter of a week. It's probably something like months. And this process will be different depending on your applications. How many applications do you have? How experiences are dev teams with ARM processors or with CI/CD tools and so on. So this is something you need to be very careful. And this can be expensive. So first, and before you deciding, oh, we are going full ARM, you need to be sure that your increase of spending on processes like CI/CD won't overcome the efficiency and the saving you are doing in ARM clusters. And the third point, very interesting, is the registry. I've seen a lot of things. I've seen images that are retrieved with the wrong architecture. So this is important. Right now, all the, or at least the common registries with the latest version support multi-arc, and it's more or less well resolved. But I know not everyone runs the latest version. Not everyone run the common registries. So you need to be sure that you use a registry that is ready to support multi-arc. You have in mind too that multi-arc images are bigger. It's not twice as big, but they are bigger. So if you are using this, you will need to have more space to store images. Network traffic will be higher, so you need to have this in mind. And you need to be very careful with the problem. I've seen registries sending the wrong image or not supporting multi-arch, but container runtime is a thing too. Container runtime is the program that runs in the node that is actually running the container. And I've seen things that make me get awake at night. Like you say ARM, but it downloads x86 image because whatever. All the container runtimes, they claim that they work with multi-arc, but I've seen issues. I think in the OCI specification 1.0, multi-arc is resolved. But anyway, I've seen issues in, for example, a cryo, which is a container engine, as recent as 6 months. So you always need to check and don't trust blindly. So the takeaway for this talk should be the cost saving can be very important, and the power efficiency. When now that we are, I think the climate change is accelerating. A green IT, it's important, and power efficiency, it's more important every day. So this is something we need to take into account. Not only the money, but the environment too. But we need to have in mind that Kubernetes in ARM is not easy. I would say Kubernetes is not easy. So moving to ARM won't make it easier. If you want production grade clusters, you need to work a lot and to check a lot of applications and to try a lot of things. So this requires a lot of work. And once the clusters are working, adapting all the applications that we are doing is not trivial. Can be easier, can be more difficult, but it's not trivial. So it requires some job. And you need to be very careful that maintaining all these duplicated pipelines and lines of development won't be worse than the power and the money that we are saving using ARM. So this is all for me. Thank you very much, everyone. And if there is any question, I can answer anything. Well, anything I know. Thank you very much.
Perfect. Thank you very much, Carlos. That was really, really good. Yeah, as Carlos mentioned, please do put any questions in the chat to the right side. I have a question myself, actually, Carlos. Watching through that, I was thinking, say I'm someone who's familiar with Kubernetes and is tempted to move over to ARM, but maybe concerned about any challenges or problems. What would you say are some what is the most difficult part of migrating to ARM, and do you have any tips for people on how they can get past that?
I think at the end of the day, you have control over your application. So migrating them to ARM is not very difficult, or at least it's something under your control. But then in Kubernetes, you need to use a lot of applications that are third party, that are open source, and not all of them are ready. And there is no quick way to have them ready. So, for example, I need to use Kong for API gateway. I need to use Istio for networking, Cilium, Prometheus, Falco. All these applications are open source, are maintained by several people, and your priorities and their priorities might not be the same. So if they don't work, you might have a problem, and that is the more difficult thing to overcome. Like having all the, I call it auxiliary software or appliances that you use to make things work, to make them ready for run. That's the most difficult part.
Excellent. Good to know. Hopefully that will help someone out. And yeah, I guess one more question: why use Kubernetes? Like, what is your elevator pitch for it? What's your favorite thing about it? In a quick short.
There's a lot of people that think that Kubernetes is the best. There are a lot of people that think Kubernetes is the worst or so complex, and I think they are both right. The Kubernetes system is designed for scalability and for reliability, and you need to use it when your applications require those. When you have a number of users that require special characteristics and special scalability, when you need like millions of users or specific requirements. If you have a blog with 10 visitors per week, you don't need Kubernetes. So you need to use it right. You need to use it when you really need it, and that's where Kubernetes writes, because it's allowed you to do things that are very, very useful for, especially for scale and reliability. That's the reason to use it. If you try to use it for everything, you will probably fail.
Perfect. Well, yeah, good to know. Good summary. So yeah, we've had no more questions coming in from our watchers. So I guess, Carlos, if there's if people do want to get in contact with you afterwards with any burning questions, what would be the best way to get in touch?
You can contact me on LinkedIn, or here in the first slide, this is my email. So feel free to drop me an email and we can chat.
Perfect. Well,
I'm
thank
easy
you.
to find.
Yeah, excellent. Well, that's great. Well, thanks once again, Carlos. That was really, really good. And yeah, and thank you everyone for watching. I think we'll call it a day here. Look forward to the next one and see you all soon. Thanks again. All the best.
Thank you.
Bye bye.